If you ever remember our tutorials about the RS module and the MODBUS, okay, and we were using Arduinos for the nodes and also for the base station. So today is the day where we will replace the Arduino for the base station or the master with Raspberry Pi Pico. Yes, we will use Pico for the master, so we will make this a standard for now for the Raspberry Pi Pico, and the rest we will maintain the nodes for the Arduino for the nodes, but only for the master we will replace it with Pico. Okay, so here is the module I will work with, the RS module or the MODBUS. Okay, and for sure, since this one is supporting 5 volt, these guys support 3.3, so we need a level converter, and we already talked about level converter and the Raspberry Pi Pico and how connected to the Arduino UNO through the UIR. This all in the previous video. So today we will continue with the RS module. Okay, so we will add RS module and level converter plus this RJ45. Okay, so next time we will use a proper RJ connector for the communication. Okay, so we no need to use the wires like we did previously. Okay, so and also I will solder all these 4 components in a proper this board. So yeah, I'm planning to solder them or arrange them like this. So this one will be here, this guy will be coming here, the level converter will be in the middle, and our RJ will be at the end. So can easily hook the cable from here and go out. Okay, so this is the arrangement, and for sure I won't solder directly to the board or to the donut board. I have this leftover, what they call it, pin headers or female headers. This is female headers. Okay, I will use them as a standoff or as a headers. So in the future, if I need to take any components, easily just take it out from the pin header, no need to desolder or solder. So yeah, so planning to use these guys, okay, where all of them will be soldered or will be placed on the female pin header. Yeah, so this is the proposed arrangement. I guess I will be arranging them like this. So yeah, let's do it. So let's go and solder them first, then we see how to do the coding. But before we go and solder them, I will show you maybe schematics or block diagram of how we will connect it or how I will connect it, especially for the RO, DE, RE and the DI, because these IOs we needed to set it in our code, and also especially for the RODI, they need to go to the UIR signals of the Pico. Okay, so yeah, let's do it. It's the time for the RS module, what they call the MODBUS protocol video. Let's move on.
Okay guys, so here I redraw the wiring diagram for our tutorial. As we said, we will use the Raspberry Pi Pico as a master to control the MODBUS or the RS module. Okay, and also I will use the RJ45 to connect the A and B wires to the next node, to the rest of the networks. Okay, so again, as we said, this guy talk using 5 volt and the Pico using 3.3 volts, so we need to use the logic converter. Okay, so here is the pin out that we needed. So here we have the RS module. This is the logic converter, high and low level, and this is the Pico. Okay, so the RS, we start from the RS, we will connect the VCC to the high side, and at the same time we will connect it to the V system or the 5 volt of the Pico. This one, this system comes from the 5 volt of the USB, which is somewhere here, the second pin on from the right. The low voltage of the logic converter will be connected to 3.3 volt of the Pico, and the DI will be connected to channel 1 of the logic converter, or from the high side. Okay, and the other side from the same channel 1 will be go to GPIO4, which is the TX from the Pico. DRE will be shorted and both connected to the channel 2, and channel 2 of the low side will go to GPIO22. This is to control the driver and the sender or receiver. Okay. Now we come to the RO. RO will be connected to channel 3, high side or high voltage, and the low side will be connected to GPIO5 or the RX. A and B will be connected to pin number 1 and pin number 8, respectively, of the RJ45, and the ground of all the modules will be connected together. Okay, so here it is. So before we talk about this, let's see the pin out of the wireless or Pico wireless. So as you can see here, we will need the V system. This one is the 5 volt. We will need the 3.3 volt V out, this one. Ground for sure. And also we will need the RXTX of UART1, which they are GPIO4 and 5, or pin number 6 and 7 respectively. And also GPIO22 is to control the transmitter or receiver. Okay, so here we go. This is how it looks like on the breadboard, but for sure we will solder out on using the zero board or the donut board. So here I use the V system to here and the ground. Here is the 3.3 volt, the second one on the right, and the ground. So these 4 rails, the left one will be connected to the 5 volt and the right one representing the 3.3 volt. So if you see here, I have the ground from each side connected to the ground, low voltage connected to here because this is the 3.3 volt, high voltage connected to here because this is the 5 volts for the V system. Now we come to the RS module, or the breakout of the RS module, RS. So the RO will be connected to this guy here, one on the high voltage, then the low voltage will be connected respectively. Because of the RO, it should be connected to the IO5, which is number 7 here. Okay, and the DI will be coming to this side, again high voltage, and the low voltage will be connected to the TX, which is IO4 here. And the DRE, they will be shorting together and be connected to this channel, channel 2, and at the low side will be connected to IO22. Okay, and at the output side of the RS module, VCC connected to the 5 volt, ground to the ground, and here is the RJ45. So pin number 1 will be connected to the A, pin number 8 will be connected to B, and the ground, I choose the middle one, I guess is number 4 if I'm not mistaken. Yes, number 4 will be the ground. Okay guys, so this is the wiring diagram that I'll follow. So you might need to follow this if you want to follow my code. Otherwise, you need to change the IOs and also change the UART that might use another UART channel. Okay, for me, I use GPIO4 and 5, which represent the UART 1. Okay, so now we can go and proceed with the soldering.
So this is how it looks like after we solder out all the components. So this is the Pico. Here is the RS module. This is the level shifter. because this one work on the 5 volt and the Pico work on 3.3, so this one will be shift the levels between these two, the logic level. Okay, here I add the restart circuit, restart button. Okay, and here is the RJ45 connector for the A and B and the ground of the RS. So the RS, now we have two ways to communicate it, to connect it, either using this pin 2, which is A and B, or we can use the RJ, so you can easily connect to here. Okay, then this wire can go to a network or here, like I just strip the wire, so I can easily connect to any other unit. Or we can just connect A and B here, and we are good to go. Okay, again, so we have finished with the hardware. Okay, so now let's link it up to our node and we start with the software. Here is the overall setup, guys. So this one will be our node MCU, which is just an Arduino UNO, and here is the RS module, which already connect all the way to the Arduino UNO, and here I connect my RJ45 network cable. Like if you see here, I connect the A and B and ground to these two pins. Then later I will just hook this one to here, to our base station. Okay, this one will be our master or base station. So yep, that's all. So this one, the master, will be programmed to send some data through the Ethernet all the way to the RS, and the RS will be send it to our UNO or node number 1. Okay, and this one just for testing, just to learn how to do the code for 2 points, or what we call as a point, 2 point, or 2 nodes only, master and the slave, only one slave or one node. Later in the future we will connect to the rest of our circuits. You know, we have actually quite a few. We have node number 1, number 2, number 3. This one we will do it later. So for the time being, I just want to teach you guys how to connect only one node to the Pico, where the Pico will be our master and the Arduino will be our slave. And again, I guess if I mention or not in the video, this Pico will be maintained and fixed in all my next tutorial as the master. That's why I fabricate all this node or all this master base station, so it will be fixed. This my trustable master base station for all my next videos and also all my next projects. Okay, so yeah, let's get to it and we will continue with the software. Okay, so we will do the code for the node, which is the base on Arduino. So yeah, here we need to use the soft serial because we will use the hardware serial to display information on the UART. So we need to include the soft serial. Yeah. So here we will use the software serial. Okay. So what else we need? By the way, this one you can just, for this software, you can also follow the previous tutorial. I won't be changed much. So we have string node address equals, this is node number 1. And also, what else we have? We need to define, we have RS/RO, and also define, what else we have, RS/DI, and also define RS/DERE. Yeah, we have these 3 control signals. So this one will be pin number 10. 11 as we connected previously, and this guy will be on pin number 12. And now we need to define the object of the software serial or soft serial. So will be software serial, yeah, so I will call it RS node of RO and RSDI, yeah. Okay, so this is the object where we declare the soft serial or software serial. What we can put in the set, so first of all, in the setup we need to declare our serial, the hardware serial, serial.begin. That one will be 9600, and also we need to declare our soft serial. Soft serial will maintain to the same power rate also. $9,600, okay. Now we need to declare the pin mode for our DERE. So we need the pin mode. Number of the pin will be RS underscore DE underscore RE. So this filler will be signed as output. There we go. Then we have what else? So since this one will be our node, so we set the digital write. Digital write of the RS underscore DERE will be low. Let's put 0. Let's see if everything okay. Did we do any mistake? Yep, we got 1. Oh, yeah, that makes sense. For sure, it cannot be like this. Since it's a string, so we expect it to be double quotation. Okay, hopefully the compiler will be happy this time. Okay, done. Good. So now we can print out some message here. So we say serial dot print line. So we can say node, and we concatenate our friend here, the node address. So node number this is ready. Yeah, so this one just for the sake of display. Okay, our node is up and running. So now what next? What to put in the loop? Let's loop. So first we need to check if the what they call the RS node, what did I call it? The RS node. If the RS node is available, okay, if we got anything from the RS node, so we need to do something here. We need to receive the data that's been received from the RS node. So I will declare a string, which is, let's say, s equal to our RS node dot read string, enter the n. The n commonly will be which is /n, or new line, I can say. Okay, So after I receive it, then usually a delay. So let's say delay of few million micros. I guess micro one of those would be like 10. No, I guess sorry, milli micros another one. 10 millisecond. Then I will bring serial dot print line. Yeah. What I will bring, I bring that I received string is this. So the received string will be serial print line same, but I'll bring the the data that or the string that the string that I received, and I store it here. Okay. So yeah, since I receive from the master or the Pico, then I'll print, okay, I received this thing. So now I will try to send, so this one is to print out the received data. Now need to reply back to the master. So now I will be serial dot print line send feedback or reply. The reply will be, let me construct the reply. So again, the string, let me call it node feedback is equal to just like done. Okay, so this will be my reply. Okay, this one just display on the serial that, okay, I will reply like this. Then I need to send the reply through the RS module. So how to do so? First, we need to bring the sender receiver pin to high, which is the RSD RE. So we go for digital, right? Our RS DE underscore RE, bring it to high. Okay. So since this filler is high, then we need to send our data now. So our node, what do I call the node? Our RS node now. I will send my data to the what they call the RS module. So I will print what? Print the node feedback for sure. Then I will give it some delay to send the data and stabilize the signal. Then I will bring the filler down again. So digital write RS DERE. So now I'll bring it low again. So activate here I activate the transmitter, here I activate the receiver. So here TX active, so that's why I send the data. Here is the RX active, so when it's come back loop again here, I can receive the data. Okay, this is how it looks P. So I believe that's it. Let's compile. I don't think we made any mistakes. Oh, we didn't. Okay, here we need semicolon. Oh, before the serial here also. What did I do? Oh, okay, there are few. Sorry guys, semicolons been missing here and there. Hopefully the compiler is happy now. Almost there. Yep, done. Okay, good. So now, yeah, we declare our soft serial, our control signal, we declare our object for the serial node of the RS, then we initialize our soft serial and the hardware serial, then we set our control of the receiver, sender and receiver pin to output, so we can control it. Then we send it to low, this means this one will be RX is active. Then we say, okay, node number blah 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 is ready. Then if the node receive anything or there's any available data in the buffer, then we will read it in the string. Then after we receive it, we print it again. Okay, we receive this, then we send a feedback. Okay, this feedback looks very plain. Let me add something here. So we have integer c equal to 0, for example. Okay, I will add some counter to our reply, so it will be like kind of a know, okay, there's something happening. I mean, if we send more than one request, we can see the counter is moving rather than just done. Okay, so here I will add our counter, but for sure we cannot just add like C, cannot concatenate a string with the integer, so we need to convert this guy into string. So string C, and again, since C only, so it always will be done 0 because initially that's 0, so you need to increase it or increment it. Yeah, this is what we call incrementing an integer. Yep, compile, done, and happy. That's good. It's a good start. So now we can burn our code into the Arduino node. Then we move out to our master or the base station. Let's go. Okay, so after we change with the code for the Arduino, now we can try to burn it. So we go here, yes, UNO, COM number 14. 17 is my Raspberry Pi Pico. Okay, go. It's compiling and should upload at any time. Okay, you're done. So we open serial, we should see something on the serial. There we go. Node number 1 is ready. So now this one, okay, and now is waiting for data to be received from the Raspberry Pi Pico. So here I connect my Raspberry Pi Pico already. If we restart it, here we go. So my Pico already up and running. Let's make a new file, new script, Python. Okay, so what to do with the Python? Let's see. First, we need to import the libraries, then needed libraries. So import, we need select for the USB, and also from machine we need to import pin and also UART, because we will use the UART to communicate with the RS. We need time and also system. Yeah, these are the ones we needed. So now we need to, let's say, create what they call pooling instance. Okay, by use pool object equal to select dot pool. Pool. Okay. Then we need to register it. So sorry, pool underscore object. So not equal should be dot register. We register the pool as a system.standard std standard input and 1. Okay. So what else? We need to now declare the UART using UART. Or yeah, let's maintain the UART, or maybe we can change. So maybe we can change to, for example, maybe the RS Master. Master UART will be equal to, for sure, should be UART of 1, and the baud rate should be 9600. Now we need to declare the TX. Where's the TX pin? TX pin number 4, and the RX should be, if you remember, guys, should be pin number 5. Okay. What next? What next? Let's print something. So print master is ready. Let's run this guy and see what will happen. Here we go. Master is ready, so it means all the previous ones should be okay. Before that, because this is the master, let me see. Master is ready. Since this is the master, because if you remember, for the Arduino, we set the, where is it? Where is the setup? Here we go. So we set this to 0. This means we start to listen. So by default, the master also could be start to listen, could be start to transmit, but we can change it later, but it's okay. So here we can set the pin to high or low, but before we set, we need to declare the REDE pin, the control pin for the RX TX. Okay, so I will call it RSDERE will be equal to machine dot pin, and this pin number 10, and machine dot pin, it should be out. Yeah. And here again, it could be high, could be low, but I'll set it low anyway. So RSDERE dot value, set it to 0, which means trigger it as a RX. Then here we need a while loop. So while true, always true. So we do something here. But before this, while true, because I'm planning to send two string 1, string 2. So let's check first. So here we what we want to do. Let's see. Okay, we start from here. So my scenario will be check the input from the USB. Okay, so I expect two type of inputs, or should be either one, could be one or two. I mean the number one or number two. Okay, so I will print printer number one for send, let's say, data 1. Okay, or printer number 2 to read data or value 2. This is just for example, for sure it's not the complete one. So here, let's say we just pass, let's start to run. Here we go into 1, into 2. So here, I guess we just need to add space. Yeah. Okay, cool. So we can continue from here. So we can check the USB data. If pull object dot pull of object 0, if I got any data from the USB, then I will try to read the character from the USB. Okay, so I'll try to read the character from the USB. So data or character, whatever, equal to system dot standard in dot read should be read 3. Okay, then let's print out after we got the data. So we can say print data. We just look back, we see whatever we got, we print back again. So now let's say if I enter 1, should print 1 again. Here we go, 2, print 2, 3, print 3. See, whatever I enter, it will print back again. Enter, print back. But you see, there's a lot of things happening here because it's not only the data. There's some headers, hidden headers like new line, or got the tab in the middle. So I need to decode it, let's say, whatever. So equal to data dot strip. Need to strip it. So now let's try again, see if it can give us a better one. No, it's still same, can see the spaces, but anyway, it's important to strip your data. Now I can check it. So now I can check the data if it is 1 or 2. So if our decoded data is equal to 1, I will do something. Let's say print it's 1, okay, and else if the decoded data is equal to 2, so I will print it's 2, delete the one, okay. Else if nothing matched, then I will say is a wrong entry, so I will repeat this message. To say wrong entry and please enter blah blah blah. Let's check again. Invalid syntax where 37. Oh yeah, there's extra dot here. There we go. So I will enter 0. Here we go. So it's wrong entry. Please enter only this one. I will enter 1. Here we go. It's 1. 2 is 2. 1 again. 0 is wrong. 2 should be okay. 5 is wrong. Okay. So now our architecture is good. So now here we need to send request 1. Here send request 2. Okay, to send the request, so first we need to set the RSDERE. We set our friend here. Actually, we need to take the whole one. Make your life easy, man. So this one should be, since I want to send, so I need to activate the transmitter, which should be 1. Okay. Then after I finish, should be go back to 0. Okay. So set to 1, then I will give time to it to stabilize, or time dot sleep. Let's set it by 2 should be enough. Then I will write to my master UART. Master UART dot write. I will write what? Right, let's say any request, because we are not doing any what they call, we don't do any analysis or parsing to the string. So this one just for sake of testing. So I can say here set data 1, for example. Okay. So set data 1, then I will give it time to be stabilized again. Give it some time to receive all the data. Let's say 0.5 here. Then I will set it back to 0. Then I will bring back again here. I will print print what? Print, okay, this is number 1. Data 1 sent already. Okay. Else I will just copy the whole thing. So this one will be 2. Else will be exactly the same, but this one will be read data 2, for example. Then here will be data 2 read. This one should be 2 also. Okay. So now let's do the testing. If I send 1, I should see, here we go. Let me open the Arduino. Here we go. So you can see here we already received something, and Node 1, sorry, receive the string and the set data on 1. Send the feedback. The feedback is sent, but we haven't received anything yet. Why? Because we didn't write the code to receive something. Okay, so how to receive something now? In order to receive the data, so here I already sent, I mean, all the above code is to send. Now I want to receive the data. Actually, not here, sorry. Shouldn't touch this, should be after we finish with our sending data. So this is all the sending data. So now our receive should be under here, because this one will be checked only if there is a data come from the USB, then we send it out. So here exactly we check and display the receive data from the RS. Okay, what can I do? For sure, I will just check if the master UART got any data. Oops, my server need. Thank you. Got any data? Excuse me. Got any data in the master? Then I will read it. So master data equal master UART dot read. Okay, I'll read it. Then I'll say decoded data equal to master data dot strip. I like to strip it. Strip our data. Then I will say, what else we can do? I believe that's all. We just print it out. So bring what? Receive data from node is this plus what? Plus the decoded data for sure. Okay. So now let's try again. Hopefully it's work. 1, send the data, but we got nothing. 2, error. String to byte, add 54. Oh yeah, sorry. So this one should be string data, and it should be like this. Yep. Okay, so I sent 2. Should be data read, but no reply. 1 only got the reply. So now if I send, 4 got reply, 2 got no reply, 1 got reply. Something happened. Okay, let me. So if I send 1, no reply. If I send the second time, then I got reply. Do you know what's happening behind? The thing is, this one will be executed very fast. That cannot catch up all the data being queued in the buffer. So it's got the reply, but this one cannot catch it. We need to make it, because this one will be run only once. Once is nothing, so it will go back to execute another iteration which might be missing. So we need to make sure this guy is executed until we got some data. We need to make sure executed until we got some data. And once we got some data, we need to print it out first, then we exit the loop. So for sure we can use while loop again. But this while I don't want to execute it always. Execute it only in one condition. Execute it if there is a command being sent. If command being sent, so this guy will be here. only if command being sent. So this guy will be here for sure. There's no command sent here, so this one we just flag it. Actually, this one should be false. But if we come to here, since we send the command here, okay, we send the command, so we need to set our command to be true somewhere here. So this one should be true because we send our command, and also here should be true. If it's wrong, for sure we need to set it to false because we didn't send any command. Okay, so once we come here, it will, since we send a command, it will directly come to here and will stay here until we got the data. So after we got the data, for sure we need to set it to false. So it won't come here again. It's just to break the condition. Then that's, I believe that's it. So now if I send 1, I should expect, here we go, done 10. Nice. So now I will send 2. We should get the reply. Here we go, 10. Done 11. Because remember in the Arduino code we add the counter plus plus with the C++ to add on, to increase the counter whenever we got a new reply. Looks is nice and looks is working for me. So now we need to continue. So now if I open the Arduino code again, I'll try to restart the guy. Can I restart like this? Yes, it's restarted now. So if I open Thony again, so I will send 1. Now the reply should start from 0 now. There we go. So now 0, number 1, then 2. If 0 should be wrong. There we go. So from here, guys, we learned that the response might be fast, might be slow. That's why the read instruction will be kinda slow, or anyhow doesn't catch the whole response. So that's why we need a while loop to keep waiting for the data until we got something, then we set it to false. Okay, so yeah, happy with the result. So we can see it's working now. Now we can send and receive data to and from the Arduino. So if I put it here, then I bring this guy. Let's see here. Here we go. So now I send 2. We should see here something. Nope. Here we go. Yeah, this is increasing actually. If 2 should be 7 now. Now should be 8. Yeah. So here, guys, how to send or receive data between the Arduino and the Pico. And later we will work on how to make or send a meaningful data to the nodes, or could be more than one node, and how to parse it, and we understand what is the requirement of this string, whether we want to set some data or read some data from the node. Yeah, so here we have reached the end of our tutorial of how to set our RS communication between the Pico as a master and also the Arduino as a slave node. I hope you have learned something new, guys. So happy learning for everyone, for those who learned something, and don't forget to send the comment to me if you have any difficulties or anything not clear for you guys. Okay, so see you in the next tutorial.